more than 60 years. This is 50,000 watt clear channel WLW. Cincinnati people depend on us.
I'm standing in front of the transmitter that originally was a Western Electric 7C. It was one of the first 50 kilowatt transmitters to be delivered by the Western Electric factory. And the transmitter ran from 1928 until the mid-1970s as the primary transmitter for WLW. The last time the transmitter was on the air in commercial service was during the millennium, and they ran it from about 10 o'clock in the evening until about 2 in the morning because it had no microprocessors in it. There was nothing to fail, so they knew they were safe. They wouldn't go off the air, where the new stuff has microprocessors. So WLW has a long history of home brewing their equipment. They used to build their own microphones, their own audio consoles, their own STL. And the Western Electric 7C was actually a grid modulated low-level exciter driving a linear amplifier. And there were 3 amplifier stages after the modulated stage, cascaded to be able to get to the power levels that were necessary at a linear output of 50 kilowatts carrier. Wow. Peak power was like 200 kilowatts at full modulation. So that technology was early AM technology and had some limitations in terms of modulation. So the Crosley engineers redesigned the transmitter and built a high-level modulator. And the original transmitter was as long as 2 transmitters are here today. When they rebuilt the transmitter, the power supply components and the modulator iron all went into the basement, and the cabinets that are here, the 4 cabinets, make up the RF section, the modulator, and then the exciters were repackaged. There are 2 exciters that are in the first rack here. That transmitter ran full-time until the mid-70s when they installed the Continental 317C that's over here in the corner. But there was an interim transmitter in the late 50s and 60s that was designed by the Vice President of Engineering, a fellow by the name of R.J. Rockwell. R.J. Rockwell had about 28 patents to his name. He was a super scientist for the Crosley organization, and he developed a 50 kilowatt transmitter, but actually started with a low power version that had no iron in the modulation path and had the ability to modulate the carrier with audio that would essentially be from a few hertz all the way out to almost carrier frequency. Wow. So it was called the cathenode transmitter because it was a direct coupled transmitter, and it was built up in the 3 cabinets that you see down here. The cathenode transmitter was kind of a cantankerous development, if you will, and R.J. Rockwell was the guy who could really make it sing, but it was very inefficient from a power consumption standpoint and could be very temperamental if things got out of DC balance because it was all direct coupled stages. So ultimately that transmitter, when Rockwell retired, the engineers converted it to a high-level plate modulated transmitter and did away with the cathenode modulation. But there are many articles out in the IEEE proceedings about the cathenode system that R.J. Rockwell developed. His patents go way back and encompass many different aspects of broadcast technology. And there are been some recent articles written and published about R.J. Rockwell. So again, two different transmitters here, the Western Electric repackaged by the Crosley engineers, and the 50 kilowatt homemade transmitter developed by R.J. Rockwell and built here on site by the Crosley folks. For those of you who don't know Jeff, WHGNM, Jeff was our Vice President of Engineering and Research and Development at Harris Broadcast. Okay,
I'm going to walk over here to the other side of the room. So this site, as you know, as Jay explained, this station had to reduce power to 50 kilowatts back in the late 20s. What year was it that they had? 1930? When they reduced to 50 kilowatts? 1939, okay. So the station's operated ever since at 50 kilowatts, which is the maximum transmitter power for any U.S. medium wave AM station. So the transmitter that's on the air right now that everybody's listening to is right here behind me. It's a solid state 3DX Harris 50 kilowatt transmitter. This is a very interesting site, unlike any place I've ever been in my career, in that there at one time were four, am I counting right? Yeah, 4 operational 50 kilowatt transmitters at one time, and 5, I guess, if you count the cathanode. But so this is the main transmitter that's on the air. The backup is a previous generation DX50. These are both 50 kilowatt solid state transmitters. The backup to that is the Continental 310C. That is a 2-tube Doherty modulated vacuum tube 50 kilowatt transmitter made by Continental Electronics. The Western Electric that Jay described to you actually operated until the millennium, 2001. In fact, that transmitter was on the air from about 10 p.m. till 1 a.m. on New Year's Eve of 2000, the year 2000, the millennium. The Western Electric was on the air, okay? And the only reason it's not operational today is that a year or so later they had a problem with losing heat. You'll see when we go to the basement why. They lost heat in the area of the basement where the Pyrex piping for the water cooling of those tubes is, the Pyrex cracked. It froze and cracked, and so they haven't replaced the Pyrex pipe. Otherwise, that transmitter could operate. I believe the Continental is still operational. I don't know when was the last time Ted had it on the air. And of course, the DX50 is operational. It's tested regularly. So these two transmitters, the Harris DX transmitters, not only are they solid state, but they're digitally modulated. So these transmitters don't have a conventional modulator like you think of in your ham rig, a high-level plate modulator. And as you'll see when we go look at the 500, that was a high-level plate modulated transmitter. It had big audio transformers. It had 180 kilowatts RMS of audio to drive the power amplifiers. This transmitter, on the other hand, generates AM in a completely different way. It directly synthesizes the RF output of the transmitter by turning on and turning off a series of modules. And I'll open the door here and you can actually see it. While it's on the air, I mean, it's operating here. You'll see these modules. These are in approximately 3 kilowatt increments. And so the audio coming into this transmitter is digitized. It goes into a modulation encoding process. And at any instant in time, the correct number of modules is turned on to generate the voltage required to synthesize the waveform. So think of this transmitter, the output of this transmitter is a high power digital to analog converter. It's an RF digital to analog converter. So if you watch these modules, they're interleaved, but you'll see the ones that are green, most of the time they're flickering a little bit. They're low in the stack, so they are from the carrier frequency, carrier level down. And some of the other modules you see winking from time to time are the peak modules. So this is all made possible by a lossless combining technique where these modules can be put online or taken offline instantaneously, virtually instantaneously, without introducing any combining losses. So the combining system in it is a series non-isolated combiner, and these are like voltage sources that are switched on and switched off to generate the total voltage required at any instant time. And then of course there's an impedance transformer and a harmonic filter and all those kinds of things you normally see in a transmitter.
Standing united with America. This is the Nation Station. News Radio 700 WLW Cincinnati.